with
طيب
how the shocking does. The uncertain the uncertainty principle. Now, back in my days, when
what
in classical mechanics, you can always measure things more and more precisely. So, if you get an apple, you can always get like a ruler, which can like
تخافش خليك دايما طبيعة قدام
you
الكاميرا.
can always get like a ruler, which let's say this is an inch, 2, 3, and you can always get more precise by adding more and more and more. But in quantum mechanics, you can never measure things as precisely as in classical mechanics because of the nature of quantum mechanics, as everything is fundamental and probabilistic.
Yes.
So, in 1927, Werner Heisenberg said that it is fundamentally impossible to measure the position and the momentum of a particle at the same time. Which means you can never know if you have a particle, we can never know its, I guess, velocity and its momentum, or its position. Delta x and we can say delta v. We can never know them at the same time. The more we know about the velocity, the less we know about the position. And the more we know about the position, the less we know about the velocity or momentum. Why? Because let's have a thought experiment. Let's say we have an electron here, and we want to look at it. When we, if we have a microscope, to see something, we need a photon to get shot at the electron and reflect it back so you can see it. The thing is, when a photon hits the electron, it bounces off of it and it changes the speed of the electron. Just like billiard balls.
Yes.
If we have a ball and you, let's say, get another ball, it's gonna hit it and it's gonna bounce away, and this one is gonna move. And this changes the momentum, which now we know the position since we saw it from a microscope, but we changed the momentum of it, we changed its speed. Now, if we want to measure the speed, we can't look at the electron. So we will never know where exactly it is, but we would know the velocity of it. The mathematical form of this uncertainty principle says that the change in position times the change in momentum, when they're multiplied with each other, they have to be bigger than some minimum value. It took scientists a while to figure out what the minimum value is, but it was found out to be Planck's constant divided by 4 pi. And this also shows that when the bigger the momentum is, the less we know about the position.
Inversely proportional.
Yes, exactly. They're inversely proportional to each other. And after that, we go to electron clouds and orbitals. How do electrons look like in an atom? And this is when we come up with a new form of the atom. In 1926, a scientist called Schrödinger proposed the wave equation. delta.